Hello dear students, good morning to all of you. Today we will discuss the time period of a simple pendulum experiment. How to calculate the time period of a simple pendulum. And this is the simple pendulum, this is the bob, and this is the length of this simple pendulum. And how to calculate the time period of a simple pendulum. Actually, this is the bob whenever it will oscillate. Whenever it will oscillate, if the amplitude of oscillation, what is amplitude? That is the maximum displacement on either side of the mean position. That is, this is called the amplitude of oscillation. This is the amplitude of oscillation. And this pendulum will execute periodic motions. Periodic motion means after particular interval of time it reaches to the same position. That is periodic motions. And also it is oscillatory motions. And also it will execute oscillatory motion, makes to and fro motion about the mean positions. Every oscillatory motion is called periodic. Every oscillatory motion is periodic, but every periodic motion is not oscillatory. So it will make oscillatory motion, to and fro motion about the mean position, and this is to be the oscillator motion is said to be simple harmonic. What is simple harmonic motion? Simple motion means motion of body is said to be simple harmonic. It makes to and fro motion about the mean position, and the limit of oscillation on either side of the mean position are equal, and acceleration is directly proportional to negative of displacement. That means acceleration is directly proportional to negative of displacement. So A is equal to minus omega square y into y. This is the acceleration. And y is the displacement from the mean position. So y is the displacement measured from the mean position. This is y. And this is acceleration. How acceleration and displacement are in opposite direction, we'll just explain it. Suppose this is a pendulum, I am just drawing another pendulum. Suppose this is a pendulum. This is the mean position, and this is a theta, and this is mg, and we will resolve it, mg cos theta and mg sin theta. Okay, this mg sin theta is the restoring force which brings the bob to the mean position. This mg resolving mg 2 component mg cos theta, mg sin theta. Mg sin theta is responsible for bringing the bob to the mean positions. So this is the restoring. This force is responsible for bringing the bob to the mean position, and this force is the restoring force. But you have displaced the bob from the mean position. You have to displace the bob from the mean position. That is why. Y means displacement, always means measured from the mean position. And this is the restoring force. Since the restoring force in this direction, so acceleration should be in this direction. Since the restoring force in this direction, always towards the mean position, so acceleration towards the mean position. So acceleration and displacement are in opposite direction, which is responsible for making the oscillatory motion next to and fro motion about the mean position. So acceleration here, restoring force and acceleration are in same direction, displacement opposite. So this restoring force is responsible for bringing the bob to the mean position, and which makes the to and fro motion about the mean position. So that is why. So condition of SHM is that acceleration is directly proportional negative of displacement. Most important factor is that whenever the body will execute SHM, the amplitude of oscillation is the amplitude. Amplitude means the displacement, the angular displacement from the mean position to the extreme position, that is called amplitude, should be less than within 4 degrees. Small, otherwise damped oscillation takes place. That means oscillation will be stopped. because of the damping force due to air resistance. So this, whenever the body will execute SHM, the amplitude of oscillation should be very small, that is within, so that this amplitude of oscillation should be within 4 degree. If it will 4 degree, then it will execute SHM and one from motion about their mean positions. And this is the length of the pendulum itself. So this is the length of the A is equal to acceleration, and omega is the angular frequency. Omega is equal to angular frequency. That is equal to 2 pi by T. T is the time periods. Time period of simple pendulum. Time period means the time taken to complete one oscillation. This is one oscillation. This is one oscillation. This is one oscillation. Time taken to complete one oscillation. And from mathematical derivations, it will be taught to in the mathematics in the theory classes. Then this gives the length of the pendulum is measured from the mean position to the center of the valve. This the L is the length of the pendulum. A point of suspension to the center of the valve, that is the length of the pendulum, and its derivation it will be taught to in the theory classes, and the time period of a simple T is equal to 2 pi root over L by G. So this is the time period of a simple pendulum. G is the acceleration due to gravity. Yes, sir. So this is the time period. If the pendulum is placed in lift, so what is time period? Time period means time taken to complete one oscillation, and it will make SHM if the amplitude of oscillation is very small within 4 degree. Otherwise, not make simple hand motion, but it will make a oscillating motions. And the time period is length of the pendulum is from the point of suspension to the center of gravity. That is the length of the pendulum. G is the acceleration due to gravity. Yes or no? And if the pendulum is placed inside a lift, and if the lift is moving upwards, is mg, weight of the body is mg, and when the lift is moving upward, whenever you will feel, whenever it actually if you are standing inside lift, when the lift is moving upward, you will feel, when you are suddenly moving upward, you will feel a jerk in downward direction. That is called the pseudo force. That is called the pseudo force. If you placed in the, if the bob is placed inside a lift, the bob will feel a pseudo force in opposite direction to the motion of the lift. Suppose this is the accelerating upward, the pseudo force will be downward. This is the pseudo force. So total downward force is equal to mg dash is equal to mg plus ma. Mg that cancelling, so g dash is equal to g plus a. So its time period is equal to T is equal to 2 pi root over L by G. Instead of L by G, it will be G dash. And time period T is equal to 2 pi root over L by G plus A. A is the acceleration of lift. Simple thing is that whenever the body is simply able to make oscillator motion, its time period is SHM, its time period 2 pi root L by G. But whenever the pendulum is placed inside a lift, its time period is equal to T is equal to 2 pi root of because of pseudo force. When the lift is moving upward direction, the body will feel a pseudo force in downward direction. So total weight of the body will be mg plus ma. So total weight is equal to mg dash is equal to mg percent, g dash equal to g percent, time period 2 pi into L by root of L by G. So the time period will decrease because this is T dash. Suppose this is T dash. T is equal to 2 pi to L by G. So the factor is G plus A. In denominator, another factor is that A is added. So time period whenever the lift is moving upward and this pendulum is plus A. So this is 2 pi to L by G plus A. So which implies T dash is less than. So this increase means this will decrease, time will decrease. So if the pendulum is placed inside a lift, so time will decreases. The lift is moving in opposite direction with a constant acceleration rate. This is the case 1. Case 2, when the lift is moving downward with an acceleration rate. What will happen? So whenever the lift is moving downward with an acceleration rate, this is the weight of the body mg. So you might have observed. Suppose you are in the 7th floor of lift and suddenly the lift is moving downward, you will feel a jerk in upward direction. That is the pseudo force. Whenever the lift is moving downward, you will feel a pseudo force in upward direction, and whenever the lift is upward, you feel pseudo force in downward direction. That is the false force, that is pseudo force. And when the lift is moving downward, the pseudo force will be ma in upward direction. So mg dash is equal to mg minus ma. That is cancel, that is equal to g dash is equal to g minus a. G minus a. So the time period t is g dash is equal to 2 pi root of L by g. Instead of g, we can write it as g dash. That is a 2 pi root of L divided by the g minus a. So what will happen? So this factor decreases. That means t dash will increase. So in this case, t dash will be greater than t. Yes or no? Yes. So case 2, that means when the lift is moving downward, the time period will increase. If the pendulum is placed inside a lift and the lift is moving downward with a constant acceleration, is the acceleration of the lift. So its time period will increase. And in the case 3, if the lift is moving either upward or downward with a constant velocity. Lift is moving either upward, this is the lift either moving upward or downward with a constant velocity, what will happen? And in the constant velocity means its acceleration is equal to 0. Its constant velocity means its acceleration is equal to 0. This is mg and that is no pseudo force. So that is a no pseudo force. That means ma is equal to pseudo force will be 0. Pseudo force will be ma will be 0. So that is mg dash is equal to mg loss ma cancelling. That ma is will be 0. That is g dash is equal to g. Just keep the duster. So in this case, g dash equals to time period t is equal to 2 pi root over L by g dash. So that is 2 pi root over L by g. So when the lift is moving, so upward or downward with a constant velocity, that will be no pseudo force because velocity is constant means acceleration 0. There is no pseudo force. So that is time period is equal to, so t dash is equal to original time period t is equal to 2 pi root over L by g. So these are the basics theory of a simple pendulum. It is also in this case, and this is the pendulum. You just see the pendulum, and if it will be amplitude of oscillation will be large, you just see if the amplitude of oscillation motions, but not simple harmonic. Simple harmonic is possible only when the amplitude of oscillation is very small, that means within 4 degree. It will be within 4 degree. Within 4 degree, it will make oscillator. It will make a simple harmonic motions. This angle of oscillation is the angle amplitude of oscillation is very small, within 4 degree. Within 4 degree, then you can calculate the time period. Yes, sir. So time period can be calculated by this stopwatch. You can calculate the time period by stopwatch, and also the most important factor is that suppose you can from the time period can be calculated from the stopwatch. That is the time taken for one complete this one oscillation. You just see one oscillation, two oscillation, 3 oscillation, 4 oscillation, 5 oscillation, 6 oscillation, 7 oscillation, you can measure the time period. So for 7 oscillations, suppose the time taken is 3 seconds, you can calculate time taken for 1 oscillation. That is called time periods. Suppose this the 10 oscillation is time taken is equal to 5 seconds. Then 10 oscillation time taken is 10 for 5 seconds. You can calculate time period time taken to 1 oscillation. Yes or no? You can calculate time period. Time period can be calculated by this stopwatch. And also almost important factor is that also the from the time period also acceleration to gravity can be also measured. From the time period of a simple pendulum also the acceleration to gravity can be measured. You just see B is equal to 2 pi root over L by G. So that is that T square is equal to 4 pi square by L by G. So L is equal to L is equal to T square by 4 pi square into G. So L is equal to G by 4 pi square into T square. Yes or no? You can calculate the time period of a simple pendulum by stopwatch and squaring the time periods. You can calculate also the L length of the pendulum is given. Suppose if you want to find out the length of pendulum, T is given, G is given, length of pendulum must be calculated in this way. Suppose time period of a simple pendulum is given from the stopwatch. As soon as gravity or 9.8 meter per second square is given, you can calculate the length of the pendulum. Length of pendulum is the point of suspension to the center of gravity. Or another way, you can also calculate the acceleration to gravity by also method of simple pendulum experiment. How? You just see. So by just use L is equal to T square into G divided by 4 pi square. So that is G is equal to L by T square into 4 pi square. Okay. So L by T square 4 pi square is equal to pi square approximate value is equal to 10 because pi is equal to 3.141. Pi square value is 10. So that is G is equal to L by T square. L by T square into 4 into 10. That is equal to G is equal to L by T square into 40. So you can calculate the L by T square graph. A length of the pendulum by T square you can divide into 40 if you multiply 40 you can calculate value of G. Yes sir, you can also calculate the value of G. And L by LT square also if L is equal to T square G into 40 into T square. So this is if G is given 40 is given, 40 is constant, G is constant, L directly proportional to T square. So you can also plot L directly proportional to T square. That means the graph is L versus T square graph.
The straight line.
Passing through the origin. Okay. So also you can calculate L versus T square graph. It is also passing through the origin. Okay. This is another type of simple. Thank you.